Hello, this is Senior Design Group 19's 3D part dispenser. The goal of this project was to design and build a machine that dispenses 3D printed parts that are ordered through the HVMC. This dispenser will be placed in the lobby of EIH and will allow students to pick parts up after HVMC hours, keep interns free of distractions, and reduce physical contact between workers and students. The dispenser features a rotating carousel design that stores and delivers a total of 32 unique printed parts. Students will be provided with a unique order number from the HVMC and will grant them access into their part-specific carousel compartment. A keypad is located on the outside of the dispenser for order numbers to be inputted into. Access doors will open upon a proper order number input and are equipped with locking solenoids and position sensors that work with the computer program to keep parts secure.
A transparent design theme shows off parts to campus visitors and students while also displaying the function and internal workings of the machine. SolidWorks was used to model and simulate the full working assembly. Fitment and performance could be predicted, though the bulk of the lessons came from bringing those ideas into reality. Dimensions were adjusted, hardware was reselected, and the gear train was redesigned to more effectively provide reliable and secure operation for years to come.
When designing this project, security of students' parts was one of the main design priorities. Both mechanical and electrical mechanisms were put in place to prevent theft of other people's parts. From a mechanical perspective, tamper-proof screws were used on the face of the machines. The door frames extended to the edges of the carousel so that nobody could fit their hand inside and reach to another cell. The 50-to-1 gear ratio along with the holding torque of the motor prevented the rotation of the carousel by hand. From an electrical perspective, a combination of solenoid locks and magnetic door sensors keeps the door's latch closed when parts are not being retrieved. A feature was implemented within the software that locks the user out if 3 incorrect entries are sequentially entered. In this case, an HVAMC employee is required to enter a special passcode before any more order numbers can be entered. This feature prevents someone from attempting to guess an order number. After the motor, solenoids, sensors, microcontroller, and screen were chosen for the final design, we added up all the required currents for each device and estimated that at peak usage, the machine would draw approximately 10 amps. A 120 volt to 12 volt, 200 watt power supply was chosen to power our project. This supply can provide a maximum of 16.5 amps, which gives us a safety factor of about 6.5 amps in case more electronics needed to be added.
A loaded, larger carousel requires more torque and precision, and we achieve this with a 12-volt, 2-amp stepper motor with an accompanying motor driver. The motor control logic we achieved with MOSFET level shifters of 3.3 from the PIC processor to 5 volts. Locking door solenoids of 12 volts are enabled with power BJT transistors for the rated current they generate. The circuit design was then finalized and begun to be soldered to the PCB board. Voltage regulators of 3.3 and 5 volts were powered off of the 12-volt supply to power the electronics. Male pin connectors were placed for the external devices for convenient and precise assembly. Entering admin mode, admin features of calibrating carousel, viewing and setting order numbers, changing admin number, and other features appeared. Setting new numbers when slots are empty begins by unlocking the doors for HVAMC staff to load in new parts, then spinning the carousel to an empty slot. A number then can now be entered and asked to save while loading in that corresponding part. Once all slots are filled that are available, a message to close the doors appears, and when completed are again locked. We fixed a metal tab on the carousel to establish a home position to return to. Upon the carousel motor rotation to a part, it travels in the reverse direction until it locates the fixed position. This allows for precision for the subsequent carousel rotations that follow, improving its robustness throughout operation.
One of the mechanical challenges was with the design of the powertrain. Since the stepper motor was not powerful enough to spin the heavy carousel by itself, a gear reduction needed to be used. Initially, the rotation was reduced by 4-to-1, though we ultimately went with a much greater ratio of 50-to-1 through a worm gear with the motor mounted horizontally. For For future improvements, we imagine there is a way to incorporate the campus's card access system and the online HVAMC database to fully streamline the process. A student would simply need to swipe an ID card. A second carousel could be made with larger sections and placed next to this one, connected to the existing circuitry, and the holding capacity would increase immensely.